Hi, and welcome to Lesson 8.2 for Pre-Calculus. So today we're going to finish up Lesson 8.2 and talk about matrix multiplication. So I know on the previous lessons we learned about scalar multiplication, where we took a number or a scalar and we multiplied that to every single entry in a matrix to get a new matrix that was a multiple of the original one. Now we're going to learn about matrix multiplication. It is very different than anything that you guys have done before. But matrix multiplication occurs when you multiply two matrices together. And specifically, it's what's considered to be a row by column multiplication. So when we're multiplying two matrices together, we have to make sure that a couple of things match up before we know if we can even multiply them together. So let's take, for example, we have a matrix A that is of order m by n. So that just means that it has m number of rows, n number of columns. So these could be any number that we want. And matrix B is in order of n by p. We can multiply these two matrices together because the number of columns in matrix A equals the number of rows in matrix B. These two numbers here are the same. So as long as our middle terms here in our order are the same, we can multiply matrix A to matrix B. And what's going to end up is a result. We're going to have a new matrix that is of order m by p. So this would be your new order of the matrix. The number of rows of your first matrix by the number of columns of your second matrix. So let's actually put this into a little bit more of a theory. So we've got two matrices here that have random numbers, and we're going to represent those by letters. So we have a 2 by 2 matrix times a 2 by 2 matrix. So the first thing that we want to do is make sure that we can in fact multiply these matrices. So we have 2 by 2 times 2 by 2. We're good. These two numbers in the middle match. So we are good. What's going to result is a 2 by 2 matrix because of our m and our p. That is a 2 by 2. So we have our resulting matrix right here. This probably looks a little strange too, but we're going to go through and figure out how to do this. So remember, I said earlier that matrix multiplication is a row by column kind of multiplication. So what that means is we are going to multiply across the rows of the first matrix and down the columns of the second matrix. So we are going to take, for our first entry, we're going to go across our first row and we're going to multiply the individual positions. So A times E, and we're going to add that to B times G. That's going to be our first entry of our multiplied matrix. So we have AE plus BG. So for our second entry, we're going to keep with our same row, but we're going to move to the second column. So now we're going to multiply A times F, and we're going to add that to B plus H. So that would be AF plus BH is going to be our second term in our first row. Now we're going to go down to our second row because we have finished both columns here. We have multiplied everything through down this column and down this column. So we are done with the first row of our new matrix. So now we're going to go to the second row and start the process all over again. So we're going to use row CD and we're going to multiply that to our first column. So our resultant would be C times E plus D times G. And that will be your term, your first term in your second row. And then lastly, C times F plus D times H. And now you have multiplied everything. You have gone across the rows, and you've done both rows, and we've gone down both columns. Okay, so this is a little confusing, I'm sure, with all these letters involved. So let's go ahead and move on to an example. So we've got the following example that we want to multiply these two matrices. First, let's make sure that we can multiply them. So this matrix right here is a 3 by 2 matrix. We have 3 rows and 2 columns. And we're going to multiply that to a 2 by 4 matrix. All right, we're good. Our middle terms match, 2 and 2. Our resultant matrix is going to be a 3 by 4 matrix. So the first thing that we're going to do, remember, we're going to go across our rows this way, and we're going to go down our columns for our entries. So we've got 2 times 3 plus -1 times -1. Okay, now we're going to move to our second one. So 2 times 1 plus -1 times 2. All right, we've done that column. Now we're moving on to our third one. So now we have 2 times 0 plus -1 times -3. And now we're moving on to our last column. So we have 2 times 5 plus -1 times 4. So now we're going to move on to our second row and do the same thing. So we're going to take this row and multiply it to each of our 4 columns. So that gives us 3 times 3 plus plus 4 times -1. Second column, 3 times 1 plus 4 times 2. Moving on to our third column, we have 3 times 0 plus 4 times -3. And moving on to our last column, we're going to have 3 times 5 plus 4 times 4. All right, now we're on to our last row. So we're going to do the same thing here. -2 times 3 plus 5 times -1. Moving on to our second column, we have -2 times 1 plus 5 times 2. Moving on to our third column, -2 times 0 plus 5 times -3. And finally, our last column, we have -2 times 5 plus 5 times 4. Okay, so now we have all of our entries, but this looks really messy. We've got all these numbers here. So now we're going to simplify. So now we're just going to do what the math says. So this is 2 times 3, which is 6. So 6 plus 1 is going to give me 7. Now we've got 2 minus 2, so that gives me a 0. 2 times 0 is 0 plus 3. So we have 0 plus 3, which is 3. And 10 minus 4, which will give me 6. All right, moving on to our second row. 9 minus 4 is 5. 3 plus 8 is going to give me 11. 0 minus 12 gives me -12. And 15 plus 16 is going to give me 31. Next, we have -6 minus 5 gives me a -11. -2 plus 10 will give me 8. 0 minus 15 is a -15. And lastly, we have -10 plus 20, which gives us 10. So this is your resultant matrix right here. This is the product of our 3x2 matrix times our 2x4 matrix. And remember, we said it was going to result in a 3x4 matrix, and that's what we've got here. 3 rows, 4 columns. All right, so that is matrix multiplication. Let's move on now. So now we're going to learn about the properties of matrix multiplication. And these are very similar to the properties that we've seen before, so we're going to go through these fairly quickly. First, matrix A times the product of BC is going to equal the product of AB times matrix C. If we have matrix A and we're going to multiply that to the addition of B and C, that's going to give us AB plus AC. Next, if we have it opposite, so we're adding matrix A and matrix B, and then we're going to multiply it to matrix C, we'll get AC plus BC. Next, we have a scalar C, and we are going to multiply that to the product of matrices A and B. That's going to give us the same thing as if we had multiplied the scalar to matrix A and then multiplied that to matrix B, or if we multiply the scalar to B and multiply that to matrix A. Last, we have what's called an identity matrix. And if we multiply a matrix by the identity matrix, we are just going to get that matrix A back. And an identity matrix is a matrix where we have ones down our diagonals and zeros everywhere else. So we've seen this matrix before, but this specifically has a name and it's called your identity matrix. Okay, now we're going to move on to one last example. So when is matrix multiplication actually used? So we've got an example here where we've got a company that sells 5 models of computers through 3 different retail outlets. The inventories for the outlets are represented by S, and the wholesale and retail prices are represented by T. We need to figure out the multiplication of these two matrices. So we've got a matrix here. We've got our 5 different models, 1, 2, 3, 4, 5. So these are our 5 different models of our computers. And we've been told that they are sold through 3 different retail outlets. Those are our different retail outlets right here. 1, 2, and 3. We can label them A, B, and C. So this is our matrix that represents the inventory that each retail outlet has of each type of computer. Remember, this is your model of the computer up top. So now we have our prices here. We've got our retail prices on the left. Oh, I'm sorry, those are our wholesale prices. So we're going to label that with a W, and our retail prices on the right for each type of computer. So this would be Model 1, Model 2, Model 3, Model 4, Model 5. These are your different models that are going down. So we want to find the matrix, or the product of matrix ST. So if you do your matrix multiplication, and I'm not going to go through the multiplication here because it'll take up a lot of time, but when you do that, first of all, can we multiply these together? Well, we have a 3 by 5 matrix, and we're going to multiply that to a 5 by 2 matrix. So yes, we can. Our middle numbers are the same, 5 and 5. What's going to result is we're going to have a 3 by 2 matrix. So when you multiply these out, you end up with the following matrix. ST equals 15,770 for your first entry. And I want you guys to practice this on your own. Make sure that you're getting these answers. And then we have 18,300. Our next entry is going to be 26,500. And then we have 29,250. Then we have 21,260. And our last entry in this matrix is going to be 24,150. Okay, so now that we have all of our entries, what does this tell us? That's what we're wanting to find out by interpret the results. This is telling us our different models, or our different stores, retail outlets, A, B, and C, and the inventories that they have for wholesale and retail. So this is giving us the inventories that they have, total inventories, for their wholesale computers and their retail computers based on the inventories that they had here. So it added up everything that they had for wholesale and retail for the different stores. So that's how we would interpret the results. So matrices are used a lot in multiplication, especially when you have lots of different data that you're wanting to consolidate and get into a more organized fashion. So that's when you'll use matrix multiplication. Okay, so that is it for today. It's a lot of information, I know, but definitely go over this lesson, make sure that you understand how to multiply matrices together, and also being able to interpret the results. You're going to have to learn how to do that for some word problems. Hope you enjoyed this, and talk to you soon. Take care. Bye-bye.